Hello, my dear children. Welcome to the mathematics class. In the previous exercise, we have discussed parametric differentiation. I hope you have learnt well. Isn't it, my dear children? Right. Now come to the next exercise. That is exercise 5.7. In this exercise, one and only simple point is there, a simple concept, that is second order derivative. What is that point? Second order derivative. Let us discuss this point now. Are you ready to listen the class? Yes. Let y is equal to f of x. Suppose f is y is a function defined in the variable x. Then we know that dy by dx is equal to f dash of x. If y is equal to f of x, then if we take the differentiation on both sides, we get dy by dx is equal to f dash of x. Consider this result as equation 1. Okay, my children. If you differentiate f dash of x is differentiable, we may differentiate equation 1 again with respect to x. If this function is again differentiable, then we can differentiate this function with respect to x again. Then what would you write on both sides? What is the differential operator? D by dx. So d by dx of dy by dx is equal to d by dx of f dash of x. Understood this step, my children? I wrote the differential operator d by dx on both sides. Understood this step, my children? Right. This implies in LHS, this notation d by dx of dy by dx is written as d square y by dx square. D square y by dx square. Remember this one, my dear children. Don't multiply algebraically d into d square y by d square x square. Don't confuse here. It is okay in the part of numerator d into d square y, but in the denominator don't multiply as an algebraic expression. Don't write d square x square. It is a wrong notation. This is correct notation. Understood, my dear children? D square y by dx square only. Don't write in the denominator d square x square. Remember this point, my dear children. Keep this point in your mind. Okay, my dear children? Right. This implies, come to the RHS, d by dx of f dash of x is there. Then we write its notation as f double dash of x. See, there two lines are there. F double dash of x. Understood this step, my dear children? Right. This is called second order derivative of f of x, because f of x is differentiated two times. Here we have differentiated one time, first time. Again we have differentiated the f of x second time. So this is called second order derivative of f of x. It is denoted by f double dash of x or d square y or y double dash or y2 if y is equal to f of x. These notation can be used to denote second order derivative. F double dash of x, d square y, y double dash or y2. All these four notations denote the same second order derivative. Understood this point, my children? Right. We remark that higher order derivatives defined similarly. Means if we again differentiate this function, we get f triple dash of x, f fourth derivative of f of x, and so on. Understood this point, my children? Right. Now come to the sums in exercise 5.7. We can start the sums in exercise 5.7. Page number 183. Page number 183. See the question number 1. First question. Find the second order derivative of the function x square plus 3x plus 2. Understood the question, my dear children? Yes. This is the given function. We have to find the second order derivative of this function. It means we have to differentiate this function 2 times with respect to x. Okay, my dear children? Right. Come to the solution part. Let us assume that given function is y. So, y is equal to x square plus 3x plus 2. Here we assumed the given function is y. Understood this step, my dear children? Right. Now, we are differentiating with respect to x. On both sides we are differentiating with respect to x. This implies what is the differential operator in that case? D by dx, right? So we wrote d by dx, differential operator on both sides. Understood this step, my dear children? D by dx of y is equal to d by dx of x square plus 3x plus 2. Understood this step, my dear children? Right. This implies in LHS, what is there? D by dx of y. What is the value of d by dx of y? dy by dx. Understood this LHS, my dear children? Right. This implies that is equal to, come to the RHS. Here we have to differentiate this function. If we observe this function is defined as a sum of 3 terms. So we can differentiate each and every term separately. So that is why d by dx of x square plus d by dx of 3x plus d by dx of 2. Understood this part, my children? We have differentiating these 3 terms separately. Understood, my children? Right. Here I wrote d by dx of y means dy by dx. Understood this step, my children? Right. Now come to the next step. In LHS, dy by dx is there. I wrote LHS as t. That is equal to, come to the RHS. See this first term, d by dx of x square. D by dx of x square. Which formula is suitable for finding the value of this one? Yes, d by dx of x power n. This formula is suitable for this one. So n into x power n minus 1. What is n here? 2. So 2 into x power 2 minus 1. What will you get? 2 minus 1 means 1. So I am not writing 1 in the exponential form. Okay, my dear children? So 2x only. Understood this first term, my dear children? Right. Plus, see this second term, 3x is there. In this term, 3 is the numerical coefficient. So we can write it before the differential operator. Previously I told you in many classes I told you, if any numerical coefficient is there, we can write it before the differential operator. We follow the same rule here also. So we wrote 3 outside or before the differential operator. Then what will be left here? X only. So d by dx of x. Understood this second term, my dear children? Right. Come to the third term. D by dx of 2 is there. No variable in this term. Means it is only a constant term. Then what is the formula? D by dx of constant? 0. So d by dx of 2 is equal to 0. Understood this term, my dear children? Right. I wrote the formulas which were used in this step. What are the formulas we used here? D by dx of x power n is equal to n into x power n minus 1. We used this formula, and d by dx of constant is equal to 0. We used these two formulas in this step. Understood, my dear children? Right. This implies dy by dx is equal to 2x plus 3 into 1. 3 into 1, because d by dx of x is equal to 1. Understood this step, my dear children? Right. This implies dy by dx is equal to 2x plus 3. This is a first order derivative. As we have found in the previous exercises, we have found here. Understood this step, my children? Right. Next, again differentiating with respect to x, we have to find second order derivative. So we have to differentiate this function again with respect to x. Then what is the differential operator? D by dx. So I wrote d by dx, differential operator, d by dx on both sides. This implies d by dx of dy by dx is equal to d by dx of 2x plus 3. Understood this step, my children? Right. This implies in LHS, what is the notation? D by dx of dy by dx means d square by dx square, d square y by dx square. Don't multiply as in the case of algebra like this, d into d, so d square y. I told you already clearly. This is the correct notation. D by dx of dy by dx means d square y by dx square. Don't write in the denominator d square x square. Don't confuse in the denominator part. Understood, my dear children? Right. Is equal to, come to the RHS part, we have to differentiate this function. If we observe this function, it is defined as a sum of two terms, namely 2x and 3. So we can differentiate these two terms separately. So d by dx of 2x plus d by dx of 3. Understood this part, my children? Right. Because d by dx of dy by dx is equal to d square y by dx square. Remember this notation, my children. Okay, my children, this is the second order derivative, notation of second order derivative. Okay, my children? Right. Now come to the next step. This implies d square y by dx square is equal to, observe this function. In this function, 2 is a numerical coefficient. So we can write it before the differential operator. So I wrote here 2. After writing this 2 before the differential operator, what will be left here? X only. So we take that differentiation, d by dx of x. Understood this first term, my children? Right. Plus, come to the second term, d by dx of 3 is there. Is there any variable in this term? No. So what is this term called? Constant term. Then what is the differentiation of this function? Differentiation of a constant function is 0. So d by dx of any constant is 0. So we wrote here 0. Understood this term, my children? Right. Since d by dx of constant is equal to 0. Understood this step, my children? Right. Next step. This implies d square y by dx square. I wrote LHS as t is equal to 2 into d by dx of x. Do you remember the formula? D by dx of x is equal to 1. Right. So we wrote that value. Understood, my children? Because d by dx of x is equal to 1. I wrote that formula here also. Understood this step, my children? Right. This implies d square y by dx square is equal to 2. This is the value of d square y by dx square. Understood, my children? Therefore, finally I wrote here d square y by dx square is equal to 2. Understood, my children? Right. Now come to the question number 3. Question number 3. I am not explaining question number 2. You try yourself question number 2. Okay, my children? Will you try the question number 2 in this exercise? Right. So come to the question number 3. If you are strong in the derivatives, this exercise is very easiest exercise. Okay, my children? Right. Find the second order derivative of the function x cos x. Understood the question, my children? What is the given function here? X cos x. What should we do? We have to find second order derivative of this function. Okay, my children? Right. Come to the solution part. Let y is equal to x cos x. We assumed here given function is y. Understood this step, my children? Right. Differentiating with respect to x. Okay, my children? Right. This implies, what is the differential operator here? D by dx. So I wrote the differential operator d by dx on both sides. So d by dx of y is equal to d by dx of x cos x. Understood this step, my children? Right. This implies, see LHS, what is there? D by dx of y. What is the value of d by dx of y? Dy by dx. Understood LHS, my children? Right. that is equal to, come to RHS. Observe this function d by dx of x into cos x. Which formula can be used here to find the derivative of this function? Yes, product rule. Consider this is u and this is v. UV formula, that is also called product rule. In 11th class, you have studied how to apply product rule. Do you remember that point, my children? Right. So u into, that is x into d by dx of v. V means here cos x. Understood this first term, my children? Right. Plus v into d by dx of u. We assumed here in our mind this is u and this is v. We applied that formula. What is the formula? D by dx of uv is equal to u into d by dx of v plus v into d by dx of u. Understood this step, my children? Right. I wrote that formulas clearly here because d by dx of y is equal to dy by dx and d by dx of uv is equal to u into d by dx of v plus v into d by dx of u. Understood this step, my children? We used these 2 points to get this step. Understood that step, my children? Right. Now come to the next step. This implies I wrote LHS as it is dy by dx. Okay, my children? Right. Is equal to, come to the RHS. First term x into d by dx of cos x, direct formula. We have already studied derivatives of some standard functions. In that list it is also there. This is a standard function. So d by dx of cos x is equal to minus sin x. Understood this part, my children? Right. Come to the second term cos x. I wrote this cos x as it is d by dx of x. This is also a derivative of standard function. This is a standard function. What is the formula? D by dx of x is equal to 1. Understood this part, my children? Right. So what are the formulas we used in this step? D by dx of cos x is equal to minus sin x and d by dx of x is equal to 1. By using these 2 formulas we got this step. Understood this step, my children? Right. This implies in LHS dy by dx is equal to, come to the RHS, minus x sin x plus cos x. Understood this step, my children? Right. Again we have found first order derivative, that is dy by dx. We found here dy by dx means we have found first order derivative. Understood, my children? Right. Again differentiating with respect to x. Then what is the differential operator? Yes, d by dx. So d by dx of dy by dx is equal to d by dx of minus x sin x plus cos x. In this step I wrote the differential operator d by dx on both sides. Understood this step, my children? Right. This implies, see LHS, what is the d by dx of dy by dx? Then how do you write the notation? D square y by dx square. Remember this notation, my dear children. Don't write here d square x square. Many students will confuse here. They will multiply, as in the case of algebraic expressions, d into d square y by d square x square. Don't confuse. This notation should be remembered. Okay, my dear children? Right. Is equal to, come to the RHS. What is the function here? D by dx of minus x sin x plus cos x. This function is defined as a sum of 2 terms. This is one term and this is a second term. So we can differentiate each and every term separately. So d by dx of minus x sin x, I differentiated here first term, plus d by dx of cos x, I wrote separately. Understood this step, my dear children? Right. Here I wrote that notation also clearly. D by dx of dy by dx is equal to d square y by dx square. Don't confuse here, my dear children. Okay, my dear children, do you remember this notation? Right. This implies I wrote LHS as it is d square y by dx square as it is equal to, come to RHS. come to this first term, we have to differentiate this first term. If we observe here minus is there, we can write minus outside. Then what will be the left function? X sin x. So it is in the form of u into v. Imagine or assume that x is u in your mind and sin x as v in your mind. So d by dx of uv, that formula is suitable for finding the derivative of this function. So we use that formula. What is that formula? Product rule, d by dx of uv rule. So u means x into d by dx of v means sin x plus v into sin x into d by dx of x. Understood this part, my dear children? Right. Plus come to the second term, d by dx of cos x. This is a standard function. We know the derivatives of a standard function. D by dx of cos x, what is the value? Minus sin x. I wrote here. Understood this part, my dear children? Right. Because d by dx of uv is equal to u into d by dx of v plus v into d by dx of u. We used this formula for finding the derivative of this first term. Isn't it or not, my dear children? Right. And d by dx of cos x is equal to minus sin x. We used this formula for finding the derivative of this second term. Understood this step, my dear children? Right. Now come to the next step. This implies we wrote LHS as it is, that is d square y by dx square. We wrote it as it is equal to minus of x into, again observe this part, it is a derivative of a standard function, d by dx of sin x. What is the value of d by dx of sin x? Right, cos x. Understood this part, my dear children? Right. Plus sin x into d by dx of x. What is the value of d by dx of x? 1. Do you remember that formula, my dear children? Right. Understood this part, my dear children? Right. Plus, here plus into minus, what will you get? Finally, sin is minus sin x. Understood this step, my dear children? Right. To get this step, what are the formulas we used here? D by dx of sin x is equal to cos x and d by dx of x is equal to 1. Understood this step, my dear children? Right. This implies d square y by dx square is equal to minus x cos x minus sin x. We multiplied by minus, then we get these two terms. Okay, my dear children? This is the last term, minus sin x as it is we wrote. Understood this step, my dear children? Right. This implies d square y by dx square is equal to minus cos x minus x cos x. By simplifying these two terms, minus sin x, what will you get? Minus 2 sin x. Understood this term, my dear children? Right. This is the value of d square y by dx square. Understood, my dear children? So finally I wrote here d square y by dx square is equal to minus x cos x minus 2 sin x. Understood, my dear children? Right. In this exercise, total 10 questions are there for finding the second order derivative. Will you try the remaining sums, my dear children? I will help you in finding the second order derivative of the given functions from the question number 4 to question number 10. Please try the question number 4 to question number 10. I will help you. Will you try the questions, my dear children, in this exercise from question number 4 to question number 10? Are you ready? Yes.